You know that feeling. Just staring down a mountain of articles, reports, research papers.
Oh, absolutely. Trying to get a handle on something complex.
Yeah, without completely drowning in all the information. It's the modern challenge, isn't it?
It really is. Information overload.
Mm-hmm.
And, digging deep often feels almost impossible for just one person.
Or even one AI trying to tackle it all step by step.
Exactly.
But what if you didn't have to do it alone? Imagine having a whole team of AI agents working together, divvying up the work.
And bringing you just the key insights.
Precisely. That's exactly what we're diving into today. We've been looking at Anthropic's really fascinating research.
On their multi-agent system, the one built into Claude.
Right. So think of it less like one AI doing a single task.
And more like a research team collaborating.
Yes, exactly. A team. So our mission for this deep dive is really to unpack the engineering behind it.
The design choices that make this collaborative system actually work.
Why does this team approach make such a difference for complex research? And, what did Anthropic learn building it?
Well, I think what's key here is understanding why research is such a good fit for this kind of team approach. As the sources point out, research isn't just a rigid checklist, right? It's dynamic.
It requires exploring different paths.
And you need that flexibility to pivot based on what you actually discover along the way.
Right. A single AI agent just following one path, one line of inquiry, it could easily get stuck.
Or miss crucial stuff, especially on those broader tasks like finding board members for a long list of different companies all at once.
Yeah, the breadth first stuff.
And that's really where having these parallel subagents comes in. They can explore different branches of the research at the same time.
Ah, okay. So each one focuses on a piece of the puzzle within its own context.
Exactly. They distill their findings, pass the key insights back to a lead agent.
Like splitting up the work. Specialized researchers.
You got it. And the results they found are pretty impressive.
I saw that. They found this multi-agent system using Claude Opus as the lead.
And Sonnet subagents.
Yeah, it outperformed a single Claude Opus agent by, over 90%?
Over 90% on their internal research tasks. That is not a small improvement.
No kidding. That's a significant jump.
It is. And a major driver they identified, it comes down to something called token usage scaling.
Okay, token usage scaling. What does that mean exactly?
Essentially, the multi-agent system distributes the cognitive load because the agents have separate context.
Their own working memory, kind of?
Right. They can process and reason over much more information concurrently than a single agent stuck in one context window.
Okay, let me see if I get this. Tokens are like the model's processing power or working memory. A single agent hits a limit. But a team of agents working in parallel, well, it effectively gives you much more thinking power applied at the same time.
That's a good way to put it. And the sources show this distributed processing power really explains a big chunk of that performance boost.
Interesting. But there's a catch, right?
Well, yeah. The flip side is that this approach uses a lot more tokens overall.
How many more?
The figure mentioned was something like 15 times more tokens than a simple chat interaction.
Wow, 15 times.
Yeah. So, this means they're most economically viable, most valuable for those really high-stakes, complex tasks.
Where the time saved or the quality of the result easily justifies that higher computational cost.
Exactly. They really shine where you need heavy parallelization or you're dealing with information that just swamps a single agent's capacity.
Okay, so how's it actually, built? The architecture they describe.
It's sort of like an orchestrator and workers model. You have a lead agent.
Takes the user's query, plans the research strategy.
And then delegates specific subtasks to other agents, the workers.
And it's dynamic, right? Not like traditional RAG that just fetches stuff that's already indexed.
Very dynamic. The lead agent can create these subagents on the fly. They perform iterative searches, they evaluate results, refine their approach.
And report back. Then the lead synthesizes it all.
Synthesizes and decides what the next step is, what to research next.
This whole design, it brings up some really interesting engineering lessons they learned.
Oh, definitely. Getting these AI teams to work together smoothly. It's not always straightforward.
Well, that's a big one.
One crucial lesson was about prompt engineering. Basically, how you instruct the agents.
How you write the instructions.
Yeah. They found you really have to, think like your agents. observe step by step what they're doing to spot where they get confused or, perform poorly.
And teaching that lead agent how to delegate properly was key too, wasn't it?
Absolutely critical. If the instructions weren't clear and specific.
Like telling the subagents exactly what their objective is.
Exactly. And what format to use for the output, what tools they should or shouldn't use. If you don't do that, you get duplicated work or just irrelevant findings.
It's like managing a human team, really. Clear direction matters.
Totally. They also found some clever ways to scale the effort, based on how complex the user's query was.
So simpler questions didn't trigger this massive, expensive deep dive unnecessarily.
Right. And kind of surprisingly, they found that the Claude 4 models could actually improve their own prompts and tool descriptions over time.
Wait, the AIs improve their own instructions?
Yeah, making the whole system more efficient.
That's pretty meta, letting the agents fine-tune their own workflow.
It's a powerful idea. And that massive speed up we talked about,
Yeah.
It primarily came from that parallelism, the leads spinning up multiple subagents.
And those subagents may be using multiple tools at once.
Often, yes. Concurrently. For those complex queries, this just slashed the research time significantly.
Okay, but how do you even evaluate if it's working well? If different teams might find the answer in different ways?
That's another challenge, evaluating these systems, because different agent teams might take different but still valid paths to an answer.
So you can't just check against one script?
Nope. They had to develop ways to judge the quality of the final outcome, not just follow a prescribed path. They used AI judges for some of it.
But human evaluation was still needed.
Still critical, yeah.
Yeah.
Especially for finding those subtle issues or biases, like agents sometimes favoring easily accessible web sources that might not be the most authoritative.
Okay. So despite these engineering complexities like debugging systems where one error can cascade,
Which can be tricky.
the core value seems really clear. Multi-agent systems are, well, uniquely powerful for these dynamic, open-ended research tasks.
They absolutely excel because they can explore these huge information landscapes in parallel.
They scale the effort way beyond a single agent.
And they adapt their strategy based on what they actually find during the process. Users are seeing real, significant time savings.
On tasks that were just bottlenecks before.
Exactly.
So wrapping this up, what does this all mean? It feels like collaborative AI agents are moving beyond just the research labs.
They're becoming practical tools and fundamentally changing how we can tackle complex information.
So here's something maybe for you, the listener, to mull over. Given this power, designing intelligent teams of agents for research, what other complex problems, maybe things currently beyond the reach of a single AI, could be solved if we applied this collaborative, team-based approach?
That's a great question to think about. Where else can AI teamwork make the difference?